Up next, we have Mr. Peter Kelly. Sorry. So maybe this is an argument for later outside. He's the owner of a company called Sourcevox in the UK, and today he's going to be talking to us about lessons learned from working with OpenSIPS every day for the past 10 years. 10 years, huh? You poor bastard. Okay, Pete.
Okay, can everybody hear me? Is that working?
It is.
Yeah. Okay. Yeah, as Alex just said, my name's Peter Kelly. Been working with OpenSIPS and precursor OpenSIPS for the last 10 years or so, more or less every day. And I was thinking about what to do the presentation on for the OpenSIPS 2018 summit, and I sort of remember going to AstriCon in October last year, and then went to FOSDEM in February of this year, and it kind of really struck me as to sort of how mature the presentations are now for various OpenSIPS related projects. You kind of, rather than kind of going into lots of detail, a lot of presentations will now talk about, you have a registrar here and you have a cluster here, so you kind of have these kind of virtual blobs which represent an OpenSIPS service or an OpenSIPS proxy. So I thought it might be nice just to kind of maybe take it back a bit and just sort of go through with everyone how we've learned over the past 10 years really to build, I guess, a basic OpenSIPS box and all the kind of components that we've had to go through and the learning exercise we've had to go through just to get ourselves in a position where we can have an OpenSIPS proxy doing some work, and then it's from that kind of proxy that you can then take what you have and build it into a cluster and a registrar and all the kind of cool things that you see in presentations. So a bit of background about me. Sort of before I came across OpenSIPS, I was a regular kind of LAMP stack developer for about 8 years. Using the usual PHP, Subversion, Perl, MySQL, Linux, Solaris, etc. Never even heard of voice over IP, and then I changed my job and discovered voice over IP. And I remember when I started this new job, one of the tasks was to kind of make the two phones call each other, which I think is the classic thing that people do when they first come across voice over IP. I remember using Asterisk 1.4, it made the two phones ring, and that was great. And I kind of moved into a project which was based on YATE. Initially we developed a calling card project, and YATE, I think it stands for Yes Another Telephony Reception Exchange. I don't know if anyone's come across YATE before. Don't know if it still exists even. And then that didn't work quite as we expected, so we rewrote it in FreeSwitch. So we got quite a lot of exposure quite quickly to Asterisk, YATE and FreeSwitch. And we kind of didn't think we knew voice over IP, but we knew how to make things happen with these pieces of software. And then we moved into some OpenSIPS stuff. And we added in a back-to-back user agent, and that's where it kind of got interesting. Because what we were doing with the back-to-back user agent was we were making it issue re-invites to re-establish media paths between different gateways and different carriers and different calling card services and things. And that's kind of when I realised that what we had been doing before with Asterisk, YATE and FreeSwitch wasn't really SIP. You kind of just calling functions in dial plans. You're in chan SIP and you're saying, answer the call, Bridget's here, do this. And you're not dealing with SIP, you're just dealing with this abstract concept of the call happening between two endpoints. And all of a sudden we had the back-to-back user agents, and we're looking at re-invites. I think we were kind of helping the OpenSIPS guys develop a module at the time as well, so it was quite intense, quite a steep learning curve for us with using the back-to-back user agents. So, the first thing I think we learned, or I learned, was that OpenSIPS isn't this magic box that you can just throw a call at and it will deal with it. You're basically given a SIP request, you're given an invite, via cancel, what have you, and you have to decide as the developer or as the person writing the script what you want to do with that invite. You can't just bridge it to a destination and everything will magically work. You have to decide what you want to do. Again, it doesn't automatically handle calls or SIP dialogues. You have to deal with the invites, and then you have to deal with the buy when the buy comes in, and you have to deal with any re-invites. So you kind of have to have this kind of basic knowledge or awareness of SIP that you didn't have to have with previous projects. So yeah, this is kind of one of the things we learned. We've got this concept now of a SIP transaction, which is the kind of the request arriving to the final response code going back. So we have a typical invite, 200k with an ACK, so there's your SIP transaction. And then we have the SIP dialog, which is the representation of the entire call from the invite all the way through to the buy when the call is ended. So they're the kind of two concepts that we learned about that you kind of have to be aware with OpenSIPS. And one of the key things for us was that OpenSIPS is unaware of a call. Once it's dealt with the invite, it doesn't care anymore about that call. It can use the SIP headers. So when the buy arrives, it'll just use the SIP headers in the buy, and that's how it will deal with the ending of the call. So it's not aware of the concept of a call. It does this by adding the record root header. The record root function in OpenSIPS, which probably everyone is aware of, I imagine, will allow OpenSIPS to add itself with channel proxies as the call flows through OpenSIPS. And then when the buy request comes in, you expect the UAC that's generating the buy to maintain that record root set. So OpenSIPS will expect to see itself in that record root set, and that's how OpenSIPS knows it is responsible for proxying that buy, and that's how OpenSIPS will know where to send the buy to for the next hop. But OpenSIPS can track calls, and it does that using the dialog module. And it kind of makes OpenSIPS more stateful. So, as I was saying before, if you have a invite transaction, OpenSIPS can completely forget about that invite. And when the buy comes in, OpenSIPS will then just proxy the buy and everything will work fine. If you start to use the dialog module, then you have to be aware that OpenSIPS now knows more about that call, and it kind of is maintaining the state of that call while it's progressing. And you get some benefits with the dialog module. You get access to a function called validate dialog, which is very useful if you're running almost a public service. You can have fraudsters that will try to inject malicious headers. They'll try to reroute the buy to force the call to end without ending the media, that kind of thing. You have a validate dialog function which just checks that any subsequent requests that come in, that they match the original record route set. And you kind of have this little check you can just use to make sure that you're getting valid SIP from your adjacent proxies. Again, there's a fix route dialog function as well, which will allow you to fix a route set if you detect there's a problem with it. So you're getting the benefit from having this stateful awareness of a call within OpenSIPS. You'll get CDR-based accounting with the dialog module. Anyone that's used the accounting module probably knows that if you don't use dialog, then you'll just get an accounting record for an invite and an accounting record for a buy, which is great, but then you have to match the two together yourself somehow, which can be interesting. You can have large volumes of CDRs. If you use the dialog module, then OpenSIPS will automatically produce a CDR for you, and you don't have that task or challenge to match the invite and buy yourself. You're then able to profile your calls. If you use a dialog module, you're able to assign an arbitrary profile or reference to each individual call and get statistics out about those calls. So, for example, if you're routing calls to a number of carriers, downstream carriers, you can assign an ID to each call, and then you can get graphic statistics out of an active OpenSIPS instance to say how many calls am I sending to BT or AT&T, various carriers. It just kind of gives you that awareness of what's happening on your proxy. And you also get an aspect of call control. So if you use a dialog module, if you made OpenSIPS aware of what's happening, then you can inject a buy into the call flow. So if you decide for some reason that you need to end the calls, you can just send an MI command into OpenSIPS, and it will send a by in both directions, and it will run the calls for you. And you also get the access to the topology hiding function, which is another topic entirely, which will allow OpenSIPS to present only itself as the proxy. So when you receive an invite from a proxy before yours, when you have the record route set going back in the 200 OK, you will have a list of all the proxies that SIP message has gone through. The topology hiding allows OpenSIPS to suppress that list of proxies, so you can basically hide your list of proxies from the person sending the invite. But that's quite a big topic within itself, but it's just one of the benefits you get from the dialog module. Okay. We then learnt that IP addresses are important, and again, this is coming from a background of using FreeSwitch, using the 8*, not really caring about what goes on. And all of a sudden, we were building platforms that were sending SIP messages to carriers using DNS resolution. So you kind of put the carrier's DNS record into the OpenSIPS module. OpenSIPS would duly do a DNS lookup to resolve the IP address, and from that moment onwards, in the SIP message itself, you don't see a DNS name, you see an IP address. And it's very important to sort of know that IP addresses are so important in SIP, because that's eventually what will end up in your SIP messages, and that's what's important when you come to try and make OpenSIPS highly available. And it's what Razvan was alluding to yesterday with the Anycast stuff as well. You have to have the same IP on the OpenSIPS proxies that you're sharing calls between. So we can make OpenSIPS highly available. And this is one of the other things that we had to do. Now, Razvan was talking about doing this using Anycast and clustering yesterday, but the kind of more traditional way of doing it, or the way that we've done it before OpenSIPS 2.4, which was only released yesterday, is by using the shared VIP. So you can use, I think there's a few ways of doing it, and I've seen other ways of doing it as well. You can use VRRPD, UCART, or KeepAliveD, and you can install these on sort of your two OpenSIPS instances here. Each of the OpenSIPS instances will broadcast with a priority to the switch or router this IP address, and the router will send all the packets to whatever the current active server is. So in normal operation, all the SIP messages will go to this server, and should anything happen, should this server stop broadcasting that IP address, then all the messaging will start to go to this server. Which again is fine, because OpenSIPS is kind of stateless by default. If an invite hits this server, it will route absolutely fine, and then if this server should go offline and the invite should start coming to this server, usually the by will come to this server, then the by will still route and the call will still complete. And that's kind of one of the beauties of how OpenSIPS routes SIP. It's stateless, but we've said that we've introduced the dialog module. So we've kind of got to assume that there's states on these machines. So if this machine should go away, then we lose that state information, and this machine is going to start getting calls or SIP requests that relate to calls that were established here. And we've just seen the functions like the validate dialog function. Those functions will start to fail because they aren't aware of the state of the calls that are arriving. So what we can do with our dialogs is we can write the dialog information to database. So it's standard part of the dialog module, part of lots of OpenSIPS modules actually, is they can flush the state information to a relational database. And this is kind of a standard practice that I think most people adopt. So the dialog information is listened to a database every few seconds, and the inactive server just sits there, and essentially when the inactive server restarts, or when you or when the inactive server starts, it can read all the current state information that's been flushed to the database by the active server. Yeah, and you can also do it with presence modules and some other modules. So it's, you've got this OpenSIPS platform that you've built. You've made it stateful with dialog module, for example. You can share the bit between two machines, so you can now have a situation where one box will fail, the other one will take over for you pretty much instantly. And you've now got a situation where that state information has been flushed to the database, so you can be pretty sure that when this server comes up, you'll have access to all the calls and all the state that you need when it starts receiving SIP messages. There are alternative strategies for sharing information between servers as well. One of the original installations that we wrote used the treplicate function to share user location information between two OpenSIPS machines. So what would happen is you would get a register to the active OpenSIPS machine, and then we would use the treplicate function here, which would then replicate that authenticated register to OpenSIPS 2. So if OpenSIPS 2 should become active, it's immediately in memory got access to all the user location information. So if we had a failover scenario, then all the registered endpoints would have no problem. They'd already be available in the second OpenSIPS instance. And again, the clustering module can solve the problem now as of OpenSIPS 2.4. So just to kind of recap where we are. Big thing for us was that OpenSIPS handles the requests, not the calls. Excuse me. The dialog module can be used to add your call-based state. The real powerful thing that we kind of got out of this is that we can handle the individual requests ourselves, decide what we want to do with them, and do the right thing with them. IP addresses are very important. We know how to make a highly available OpenSIPS pair, and we now know how to share information between OpenSIPS instances. Okay. So we kind of had all that platform set up, and we were kind of happily receiving calls, and we were getting some quite big numbers. I think one of the proxies pairs was up to kind of 8,000 calls per second, and it was all working quite well. And this was before OpenSIPS 1.7, and we ran into a problem because we were writing CDR information directly to the database, a MySQL relational database. And we ran into basically a classic I/O issue. So OpenSIPS is very, very, very I/O dependent. And one of the things that we've learned quite strongly over the past years is that you need to reduce I/O as much as possible when you're writing your OpenSIPS configuration scripts. This is just a dump. This is just a dump of the OpenSIPS process list of one of our OpenSIPS servers, and you'll see there's 1, 2, 3, 4, 5, 6, 7, 8 UDP receivers on port 5060. That means OpenSIPS can process simultaneously 8 SIP requests, which is fine because a processing of a SIP request happens in a matter of milli or even microseconds. It receives the invite proxy on it and it's dealt with. But the problem we ran into was that when we received the back, the CDR was being written to a relational database, and the relational database was receiving such a high volume of writes that it was locking. And when the database was locking, the OpenSIPS processes were waiting for the database to return that it had received the insert. And it was causing a backlog of SIP. So these 8 SIP receivers were no longer available to receive any more invites. As I said, there was a platform that was sort of peaking at 8,000 calls per second. So you're receiving 8,000 invites per second or requests per second, and you're all of a sudden waiting for a database to write a CDR. It caused a big problem. We kind of came across the sort of classic cases. So if you're querying a database, then you're going to have an I/O issue to deal with in your OpenSIPS configuration. especially writing to a database. As I said before, OpenSIPS 1.7, the OpenSIPS used to write the CDRs in real time as it received the buys. And I think it was 1.7, but from 1.7 onwards, there's now a separate process that's used to do extended inserts. So if OpenSIPS needs to write to a database, it will hand it off to the separate process, and a separate process every 5 or 10 seconds will then just do bulk inserts into the database. So that I/O issue has been removed. You can also have problems with DNS lookup, and I do see this quite frequently. Even on controlled environments where people have their own DNS servers local to the OpenSIPS clusters, particularly on Windows DNS servers, you can have delays in resolution. And delay in resolution obviously is an I/O problem because OpenSIPS is waiting for that DNS resolution to happen. So, I mean, there are strategies around that. You can use IPs, you can store things in the local resolver, or there's a module now called DNS cache, which I think Vlad wrote a few years ago, which allow OpenSIPS to cache DNS results, so you can kind of just get rid of that problem as much as possible. Yeah, as I've said, pre-OpenSIPS 1.7, you have this deadlock issue. If you're dealing with a large relational database, you can't really control when it's going to decide to deadlock or not, so you need to eliminate that problem away from your OpenSIPS proxy. And after 1.7 we have this new process. And I did have a slide that described how we solved this issue before 1.7, but I don't know where it's gone. There's a module called DB Flat Store. Has anyone come across that module or used it before? But that's the module we reverted to because we couldn't write to the relational database anymore. It was deadlocking all over the place. The module DB Flat Store writes relational data to a flat file on disk. So we ended up in a situation where we're writing all the CDRs locally to disk using DB Flat Store as a stand-in replacement for DB MySQL or DB Postgres. And then you end up with all your CDRs written locally, and then you just pull them off, put them into RabbitMQ queue or something, and you can process them after the fact. And that's actually ended up being a really nice design pattern that we've used lots and lots of times over and over again, because it just isolates each OpenSIPS instance to its own literally its own instance, or its own machine, or its own container. You're not relying on these third-party applications when you don't need to. So another thing that we've kind of come to the conclusion about over the past years as well is that when you're dealing with relational databases and OpenSIPS, you have what we can kind of consider 3 types of data. So we have the transitive data, which we kind of class as dialogue or present state data. It's useful data to have while your calls are in progress. But you don't need the data once the call's gone. You're not really that bothered if you lose that data. It's not business critical data. You have the persistent data that's used to build and configure your application, such as dial plan, dynamic routing, and then you also have your transactional data, such as your CDRs. And sort of as we've been refining things and improving things over the years, we've kind of come up with this design pattern / strategy, and it seems to work well. It does work well. And what we tend to end up doing is having the memory tables installed locally. So we have a local instance of MySQL or Postgres, for example, a lightweight relational database. And then the dialog information will be shared between the 2 OpenSIPS machines in a highly available pair. And we use memory-based tables. So we're pushing fast dialog information all the time, and then because it's in memory, we don't have any I/O issues. And then we use remotely managed databases for reading information, and also for eventually writing CDRs too. So deploying to multiple machines. So we know that high availability is possible with OpenSIPS. We know that most reasonable installations will have more than just a pair of OpenSIPS boxes. So how can the configurations be managed easily? Well, we come across people installing OpenSIPS, and we know that it's kind of considered normal at the beginning to kind of just hard code information into the configuration file, such as here, kind of with your hard coded IP address here. What you can do is abstract it away using M4 or ERB, sort of Ruby templating or similar. So you kind of end up with a situation where you have a template file with all the kind of variables that you need, and then you have the definition of your variables in another file. And then you can then end up with two files, your configuration scripts and then your variables that are needed for your server instances. And it kind of makes it easy for source control checking. It means that you can merge the template with variables, and you can control that yourself with your deployment scripts. You can systematically check the configuration files, and you can basically deploy OpenSIPS very easily. So all kinds of environments, your VMs, your master-slave situations, and your containers. I'm going to skip past this one because I'm running out of time, aren't I?
You have?
Do I have an extra 5 minutes?
No.
Okay, I'll skip past this one. I'll put a link up to where the slides are if anyone's interested. So these are kind of the extra tips that we kind of have for building applications that we've learned over the years. Always authorize your invites and registers, no-brainer. People, for some reason, always seem to think that you have to be registered to make a call. That's not the case. Each invite will be separately authenticated, so you don't have to be registered to make a call. Drop every packet that you don't want as soon as you see it. So if you're not going to deal with publishers or subscribes, just drop them at the top of the script. There's no point in dealing with them, they'll just cause problems later. Permissions and pipe modules are really useful for handling denial of service attacks, so just restricting traffic that you don't want to have accepted in your proxies. Beware of cancels. They look like normal requests, but they're not. The cancel has attached to an invite, so they're dealt with slightly differently in the OpenSIPS script. You can't just deal with a cancel as though it was a normal request. And log everything. This is a really, really good tip. I noticed Eric was doing it yesterday in his examples. Everything that happens in your script that's meaningful, just log it. Log it, and then when you're debugging later, you can just find out what happened. And it makes life a lot easier. So yeah, and kind of the point of the talk was that you've got to kind of go through all these things. You go through the kind of high availability, the awareness of what SIP is, the awareness of how to program OpenSIPS, and it's only at that point that you can then start building your actual application. And once you build your application, then you can start considering the future, which is kind of what these guys have been talking about over the last few days: your clustering, your WebRTC, any kind of containerization. And there we go. It's a big topic, and I think it's so big I've overrun.
Apparently, yes.
It takes time and understanding. Once you've got that core basics, you can kind of do anything with it. And that's the end. Thank you.
Sorry.